First of all, this is a handout of the PowerPoint presentation titled Status of Measuring Instruments of Reactor Pressure Vessels and Primary Containment Vessels. We already explained the current status of the reactor water injection system last Saturday, and in the future we will give a presentation on how to achieve the cold shutdown of the reactors. Today we will explain how we confirm that the reactors have been in cold shutdown, that is, the status of the measuring instruments, etc. As stated in the preface, we're going to present to you the status of the measuring instruments of the reactor pressure vessels and the primary containment vessels, which can be used for judging the achievement of the cold shutdown. Mainly, we would like to focus on how the measuring instruments measure the water level, the pressure and the temperature, and what situation they are currently in. We will explain the status of such measuring instruments today, but the actual measured data are uploaded in the plant parameters section on our webpage as they have been so far. Let's move on to the status of the data. Please look at slide number 2, titled Status of Measuring Instruments of Reactor Pressure Vessels and Primary Containment Vessels. In the vertical line, there are the numbers of each measuring instrument from above, the reactor water level, the reactor pressure, the temperature of the reactor pressure vessels, the pressure of the primary containment vessels, and the water level of the primary containment vessels. In the horizontal line, there are the summaries of the current situation of each unit, units 1, 2, and 3. Mainly, the items in green or light green indicate that the measuring instruments in the items are thought to be proofed or function properly. Items in yellow indicate that we suppose the measuring instruments are sound, but the data has not been measured precisely yet. And items in pink indicate the summaries concerning the other ways of measuring to be considered in the future. As for the items in yellow, that is the reactor water level of units 2 and 3 and the reactor pressure of unit 3, we will measure them, and as for the water level of primary containment vessels of units 2 and 3, we are now considering the means for measuring. Next, let me explain the water level of the reactors. Please look at the next page, slide number 3. As reported several times before, the water level of the reactors is measured as shown in this figure, in a way that the condensate pot is substantially filled with water and the level is the measurement criterion. If the water level varies, the pressure on side H printed in this water level gauge varies accordingly. With this variation and the hydraulic head pressure on side L, which is constant, we convert the difference of the two pressures into the water level. This is how we measure the water level. Therefore, if there is not sufficient water in the condensate pot, the hydraulic head pressure, that is the water pressure, is not measured properly, which means we cannot measure the water level properly. Please proceed to the following slide. Regarding the situation of each unit, and as for Unit 1 at present, we finished the calibration of the water level gauge on May 11th, and the condensate pot of this water level gauge, named the L side, is filled with water. Regarding the water level in the reactor at present, it is undergoing downscaling so that we assume that the water level in the reactor of Unit 1 will be more than 5 meters below from the core support plate. Now we are injecting water at the rate of approximately 4 cubic meters per hour. However, we estimate that water is leaking from the damaged part of the pressure vessel. The situations of units 2 and 3 are described on the right side. As for Unit 2, we conducted a calibration once, but the water from the L side evaporated and the condensate pot has not been filled with water yet. Therefore, we think that the water level gauge is in imperfect condition. In addition, regarding Unit 3, such calibrations have not been conducted. We will develop an appropriate work plan to continuously conduct water filling in the condensate pot. Also, branching at the L side enables us to measure the pressure in the reactor. Please proceed to the following page. The mechanism of the measuring temperature in the pressure vessel and containment vessel is described on page 5. Regarding the temperature in the reactor pressure vessel and the primary containment vessel, we are measuring the temperature with a thermocouple. Please see the example figure. If the temperature shift appears at the welded place of copper, metal A, and constantan, metal B, a voltage differential will be created at the low temperature part. Then, the voltage differential is converted into temperature and so indicated. The thermocouple itself is encapsulated in the point of the rod shown in the left side of the picture below. Regarding the temperature detector, there were detectors such as an overscale exceeding to an upward and a downscale exceeding downward so far. But basically, for other devices, the malfunction mode is limited to such things as disconnections, earth faults, short circuits, and mixed circuits, etc. And we think that the data collected at the moment is reliable to some extent. We are not sure that the accuracy of the detectors of each thermometer is within the limits of calibration or not, but according to the overall trend, we think that such temperature estimates will be probable. Also, recently, we can change the water injection rate to the reactor, and it appears as the temperature shift. Therefore, we think that the soundness of the thermometer is secured on. Next, we would like to explain the pressures of the primary containment vessels on page 6. We estimate the pressures using pressure indicators where we have been currently injecting nitrogen gas. We think we can correctly measure the pressure of Unit 1 as we finished calibrating the pressure indicator of the dry well at the calibrations on May 11th. In addition, we think the indicators of Units 2 and 3 are in sound condition as we compare the instrument readings of temporary pressure indicators written as a temporary PI in the line where nitrogen gas is injected with those of the pressure indicators of the dry wells and those of the central control rooms, though we have not calibrated the so-called main bodies of the pressure indicators of the dry wells. Therefore, we evaluate how we can measure the pressures of the primary containment vessels. Next, we would like to explain the water levels of the primary containment vessels in the upper part of page 7, the last page. Until now, we have been considering how to measure the amount of water accumulated in the primary containment vessels as water has been leaking into them. We would like to explain a little about the slight differences of the basics of measurement from Units 1 to 3. We can measure the pressure of Unit 1 on the left at 2 points. The instrument reading in the upper side indicates the pressure in the dry well as we observed in the central control room. The other one does that in the nitrogen supply apparatus and is a pressure indicator for nitrogen injection. As illustrated in the figure, we think we can, in principle, measure the water level within the dry well by the difference between the pressure of the dry well and that of nitrogen injection, as the water level of the primary containment vessel is higher than the measured point of nitrogen supply apparatus, and the pressure indicator of the nitrogen supply apparatus receives the hydraulic head pressure. In addition, Units 2 and 3 have similar measurement basics. They have pressure from the nitrogen supply apparatus as illustrated in red, and another one from the hydraulic head pressure of the suppression chambers as the pumps in relation to the discharge pressure indicator whose water comes from these suppression chambers in the residual heat removal system do not basically work currently. Therefore, we think we can also estimate the water levels of the primary containment vessels if we can subtract the instrument reading of the discharge pressure of the pumps in the residual heat removal system from that of the nitrogen supply apparatus. We have slightly different approaches to each of the units, 1 to 3, but have been currently considering methods to theoretically calculate water levels in the primary containment vessels and will continue to work on this. We can evaluate whether the cooling, including the fuel that has leaked outside of the reactor pressure vessels, is achieved by confirming the water levels, as we can assume that there is damaged fuel in the primary containment vessels which has leaked from the reactor pressure vessels. Finally, we would like to explain the summary and future policy. We think that as a whole, we have effective data as plant-related parameters, though there are some instruments that we cannot monitor. Hence, we will comprehensively evaluate such data and continue measuring and evaluating data to achieve a cool shutdown in the future. We think the functions will be recovered to measure the water levels of the reactors of Units 2 and 3 and the reactor pressure of Unit 3 with the development of the cooling of the reactor cores, though the time has not yet been determined. At the end, we are preparing to measure the water levels of the primary containment vessels, as this is useful information to estimate the conditions inside of the primary containment vessels. This ends our explanation of the status of the measurement instruments of the reactor pressure vessels and the primary containment vessels. Thank you.